In the last lecture, we had studied about finding the centroid of certain areas. For example, we learned that for a triangular area, the centroid would be exactly, for example, if we take a right angle triangle, the centroid of this right angle triangle would be at a certain location from where the perpendicular distances, if measured, would be exactly one third of the respective bases. So if this leg of the triangle is H and if this leg of the triangle is B, then from this end it would be B by 3, and from this end the location of this will be H by 3. Similarly, we learned that for a semicircle which, as can be clearly seen, is a symmetrical object about the vertical axis. Well, obviously, if the semicircle is drawn like this, then it is symmetrical about the x-axis. And one thing about centroids that we learned is that it always lies on the symmetrical axis or the axis of symmetry. So if there is any object for which you can identify the axis of symmetry, then you can be 100% sure that the centroid will lie somewhere on the axis of symmetry. Now the only thing is you have to locate at which point on the axis the centroid is lying. So it was again learnt by us that for a semicircle, on the centroidal axis or the axis of symmetry, the centroid lies at a height of 4r by 3. This height is 4 times r by 3 pi. And what is r here? R is the radius of the circle or your semicircle. Similarly, you also learned that instead of a semicircle, if you have a quarter circle, again the same 4r upon 3 pi distance is repeated. So if this is the centroid of the quarter circle, then distance is measured by taking this point as origin. You will find that this distance as well as this distance, that means the location of the centroid here, will be 4r upon 3 pi. So this you have to remember, the term or the quantity 4r upon 3 pi has to be remembered by you. This pertains both for a semicircle as well as for a quarter circle. For a rectangle, there is no deliberation at all that is required. You don't have to think much. For a rectangle, you know where the centroid would be. So if a rectangle is given anywhere, you can simply say that draw the bisector of these two sides, draw the bisector of these two sides. The point where these two bisectors will meet is the centroid. And again, the concept of symmetrical axis is applied here. Rectangle is a perfectly symmetrical image. So if the y-axis is drawn, you see that there is perfect symmetry on both sides. If the x-axis is drawn through the center, you see that there is perfect symmetry on both sides. So using the concept of axis of symmetry, you can directly guess the location of the centroid of a rectangle. You don't need any formula. You can simply say that since the rectangle is symmetric both along the x as well as the y-axis, you simply draw these two axes through the centers of the sides and you will automatically get the centroid of the rectangle as the meeting point of these two axes. The concept of centroid, center of gravity, center of mass, etc. was already understood by us in the previous lecture. And now today what we are going to learn is the method of moments for finding location of centroid of any area. Now by any area means I can create complex shapes for areas. I can give you an area like this. There is a triangle, there is a rectangle, and there is a semicircle. So this area would not be actually demarcated like this as I've drawn here. This area would more or less look something like this to you. So as you can see, this is a typically complicated area, or rather what we would more accurately call it as a composite area. Now let us understand what is the meaning of a composite area. Composite. Composite means something that is obtained by combining different smaller entities. So it is up to me, or up to you rather, to find out what are the constituent elements of this whole composite area. Now intelligently you can say that if I draw an imaginary line here, I get a triangle. If I draw an imaginary line here, then I get a rectangle and a semicircle. So individually, you know how to find the centroids of a triangle, the centroid of a rectangle, and the centroid of a semicircle. But in a combined fashion, if a composite like this is given, where would the centroid of this overall area be located? Now, in order to solve such questions, which are commonly asked in your RTO exam, we have to learn the method of moments. Now, to start with that, let us slowly bring up our concept of moment of something. Now, look at this slide. Distance of any entity. Now, we are starting with the concept of method of moments, but before that, you have to understand the concept of the distance of something measured from an axis. So, I'm saying that distance of any entity from an axis is equal to distance of its centroid from the axis. Now let us see what is the meaning of this statement. Let me first draw the coordinate axis. This is the y-axis. This is the x-axis. Now I draw a rectangular area whose vertical side is 2 meters and horizontal side is 3 meters. Okay. And now the next question that I am asking you, how far is this rectangle from the y-axis? Now most of you would immediately say that I can take an imaginary perpendicular distance from this. So the shortest distance that the rectangle is placed at from the y-axis is this. So let us say this distance is 2 meters. So is the answer to the question that how far is this rectangle from the y-axis? Is the answer to this question 2 meters? No. The answer to this is 3.5 meters. So once again, the question is how far is the rectangle from y-axis? And the answer is 3.5 meters. How? Because the distance of any entity from an axis is always equal to the distance of its centroid from the axis, not the nearest edge. So although visually it might seem to you that this is the edge that is nearest to y-axis, so the distance of this edge from y-axis should be the distance of the rectangle from the y-axis. But technically, according to the definition of distance of entities from any given axis, you have to first locate the centroid. So if I first locate the centroid of this rectangle, which all of you, I'm pretty sure you know that it should be at the midpoint of the horizontal line as well as at the midpoint of the vertical line. So this centroid would be actually 1.5 meters from the edge, and the edge itself is at a distance of 2 meters from the y-axis. So what is the distance of the rectangle from y-axis? It is 2 plus 1.5. So this is the overall distance of the rectangle from the y-axis, and hence it is 3.5 meters. Now I want some of you to put on the microphone and give me the answer to this. If the bottom edge of the rectangle is at a distance of 3 meters from the x-axis, please, I repeat, if the bottom edge of the rectangle is at a distance of 3 meters from the x-axis, what is the actual distance of the rectangle from the x-axis?
4 meter.
4 meters.
4 meters is the correct answer, because once again the concept of distance of anything from an axis is always the distance of its centroid from the axis. So as you can see that this is the centroid of the rectangle. You don't measure the distance of the rectangle from x-axis as the distance of its nearest edge. This is wrong. The distance has to be the distance of the centroid from the x-axis, and that is 3 meters is the distance up to the bottom edge, and 1 meters is the distance to the centroid. So 3 plus 1, 4 meters is the correct answer. Now I hope that this concept is clear. The distance measured for any quantity. So this concept not only goes for areas, this goes for lines, points, masses, areas, everything. Okay. So just in order to see how much you have understood, I again draw the x and y coordinates. There is a line segment that I am drawing, and this line segment is 3 meters in length, and I want to find out the distance of this line from y and the distance of this line from x. Now as it might seem very convenient to many people, you would say that this is the distance of the line from the y-axis and this is the distance of the line from the x-axis, which now you know is absolutely wrong, because you have to take the location of the centroid of the line, which is nothing but the midpoint of the line, and you have to identify the distance of this centroid from the y and the distance of this centroid from the x. So these are the actual distances, and if you take it as origin, you can also say that x bar comma y bar is given by these two quantities. So this is x bar and this is y bar. Now please note that the distance from x-axis is y bar and the distance from y-axis is x bar. Why is it so? Because the distance from y-axis is measured horizontally and therefore it has to be entered as an x quantity. The distance from the x-axis is measured vertically and therefore it has to be entered as a y quantity. So this is the concept of centroid and the distance of any quantity from the axis if it is asked of you. Now let us go back to the actual concept that we wanted to study. We wanted to study method of moments. So it is obvious that there has to be something called as a moment in the concept that we want to study. So let us come back and discuss the concept of moments. So as we know the concept of distance of objects, now we want to understand the concept of moment of objects. Now everybody knows that moment of the force is called as torque, right? Now there is something that most of you might not be knowing, and that thing is that a moment can be taken for anything. You can take the moment of a line, you can take the moment of a particle, You can take the moment of mass. You can take the moment of an area. So you can take the moment of literally anything. You can stand in the center of your room, wherever you are studying right now, and imagine an imaginary axis passing parallel to you at a certain distance. You can take your own moment. It might found it might be found a little bit funny for many of you guys that you are taking your own moment. But yes, there is no restriction on moments. Moment simply means a quantity multiplied by its distance from any given axis. That's all. That is the concept of moments. It starts and ends there. So if I say that this is the origin for x and y axis, and I have a small square of, let us say, side 1 meter by 1 meter, and I'm giving you these distances. This is 2 meters, this is 2 meters. First of all, what I want you to do is give me the value of x bar comma y bar. Anybody?
2.5, 2.5.
Very good. It is 2.5 comma 2.5. The distance of the centroid has to be calculated, which is this distance, this is x bar, and this distance, this is y bar. And both of these, as you can simply see, is obtained by adding zero point 0.5 and zero point 0.5 to the given distances. So it is 2.5 comma 2.5. Now I want to find out what is the moment of this area. This complete area is given, and now I want to find out the moment of this area about x-axis. So according to the definition of moment, I will simply write it for you. Moment of anything. I am writing literally anything because this anything is not necessarily an area. It could be a particle, a mass particle, a complete solid body, even a line segment, you yourself standing in the center of the room. Anything can be used to find a moment of itself. All you need is an imaginary axis and the distance of the object from the axis. So moment of anything is equal to object quantity. Object quantity means if the object is an area, then the area itself in meter square is the object quantity. If the object is a mass, then the total mass of the object is the object quantity. If the object is a straight line, then the object quantity is the length of the line. So object quantity multiplied by distance of its centroid from the axis. This is the definition of moment. Moment of anything is equal to object quantity multiplied by distance of its centroid from the axis. That's it. So now we come back to this question. What is the moment of this area about the x-axis? What is the
Two,
answer?
2 meter,
2 is
two
wrong.
meter.
2 meter is wrong. Moment of area about the x-axis. Now go by the definition. First of all, what is the object quantity? Object quantity of the area is the area.
2.5, 2.5.
Yes, the answer is 2.5. But again, there is something lacking in your answer. The unit that you gave is wrong.
Meter cube.
Yes, the answer should be in meter cube. Now you are correct. Now let me clarify it for the rest of the guys who are not able to guess the correct answer. Object quantity is the area of the square, which is simply obtained by 1 meter multiplied by 1 meter. So area is equal to 1 meter square. This is the object quantity. Now this has to be multiplied with distance of its centroid from the axis. Now which axis was I talking about? I was talking about the x-axis. And again, the distance of this area is equal to the distance of its centroid. And that was already found out as 2.5 meters. So the moment of this area is equal to area multiplied by distance from y, sorry, from x. So that is equal to area is 1 meter square multiplied by distance from x is 2.5 meters. So the answer is the moment is 2.5 meter cube. This is the correct answer. So now you have understood the concept of moment of an area. So from now onwards, if I give you any area and an axis, I'm pretty much sure that you would be able to find the moment of that area about any given axis. Okay. Now, as a part of a practice of the learned concepts, let me just give you another question. Now please pay close attention because you are supposed to solve the question. I will not be helping you out in this regard. The y-axis, the x-axis. This is the origin. A semicircle. This is the center of the semicircle, and I am giving you the distance of the center of the semicircle to you as 2 meters. I want you to find the moment of this area about y-axis. About y-axis. This is the area. Find the moment of this area about y-axis. Anybody can
4
attempt.
pi.
What is your
Sir,
answer?
zero.
Zero.
4 pi. 4 pi.
Four.
Pi.
2 pi meter cube.
Okay, I guess I am not getting any clarity in your answers.
Sir,
So I will.
12.56 meter cube.
Okay, one answer is 4.56 meter cube. We will check
No,
whether
sir.
this is
12,
correct or not.
12.56 meter cube.
Okay, somebody else is saying 12.56 meter
Five
cube.
six.
We'll see.
4 pi meter cube.
We'll see. We'll see. Now, please listen to me how this is solved. First of all, the concept of moment is area itself has to be obtained multiplied by distance from the said axis. Now, in this case, the distance of the centroid has to be taken to the y-axis. So, in order to do that, first of all, you have to locate the centroid. This is not the centroid, please mind it. If anybody has taken this as the centroid, then you are absolutely wrong. First of all, you should know the concept of the centroid, and you know that for a semicircular area, the centroid of the semicircle lies somewhere around here. This is the centroid. And what is the distance of this centroid? This is actually 4r upon 3 pi from the base. But if I ask you What is the distance of the centroid from y-axis? Now, in order to find the distance of the centroid from y-axis, you do not need this formula. This is the trick here. Because if I had asked you the distance of the centroid from the x-axis, then 4r upon 3 pi is the correct answer. Okay. The centroid, as you can see, is clearly, undoubtedly at a distance of 2 meters from the y-axis. So if you had been given the task of finding the centroid instead of finding the moment, the question would have been like this: x bar comma y bar. How much is this? So you would say x bar is the distance of centroid from the y-axis. So this x bar is 2, and y bar is the distance of the centroid from x-axis, or the vertical distance, and this is 4r upon 3 pi. So this is the location of the centroid of the semicircle. But you have not been asked the centroid of the semicircle. You have been asked to find the moment about y-axis. So you have to take the area of the semicircle. What is the area of the semicircle? It is pi r square by 2. Since it is a semicircle, pi r square is the area of complete circle. So pi r square by 2 is the area of semicircle. So area is pi r square by 2 multiplied by the distance. Now distance to which axis? We are talking about moment about the y-axis. So you have to simply find the perpendicular distance of your centroid from the y-axis. Now if this centroid is anywhere on this vertical line, you know that this distance remains unchanged. So there is no doubt that the distance d from the y-axis that we are talking about here is nothing but 2. So the moment of the given area about y-axis is pi r square by 2 multiplied by 2. 2 and 2 cancel out, and if you calculate this by using your calculators, radius of the semicircle is given as 2 meters. So 2 square is 4. So what is the value of 22 multiplied by 4 by 7? That is the correct answer. Okay. How many of you got it right? Can anybody give me the correct calculation for 22 by 7 into 4?
12.56.
12.56. This is the correct answer. This is the wrong answer. Now, I will repeat the question with a slight difference. What is the moment of this area about the x-axis? Now the question has been changed. Please try to understand. Now I'm asking you the moment of this area about x-axis. Now I expect everybody of you to give the correct answer. Again, the formula remains the same. Area multiplied by distance of centroid from the x-axis.
5.3 meter cube.
Okay, let us see. Area is
5
pi r square by 2. Again, area is the same. Multiplied by, now the distance that I'm asking is of the centroid from the x-axis. So I'm talking about this vertical distance from the x-axis, and this is 4r upon 3 pi. So now I will put 4r upon 3 pi. This is the distance of my centroid of the area from the x-axis. So pi and pi can be cancelled out. 2 and 4 will cancel out to give you 2. So this is 2r cube upon 3. And if you simply use the value of r as 2 meters, which is given in the problem, this will be simply 2 raised to power 4 divided by 3. What is the answer to this?
5.3
5.33
What is the unit?
meter cube.
Meter cubic.
meter cube.
Because
Meter cube.
area has a unit of meter square and the distance has a unit of meter. So meter square multiplied by meter will give you meter cube. So this is the correct answer. The moment of this semicircle about the x-axis is 5.3 meter cube. Now I hope the concept of moments of areas is clear to you. And now we can discuss the concept of finding moments of complicated or composite areas about a given axis. So for your convenience, I will take up a very simple figure first, and then we will move on to more complicated figures. Y-axis, x-axis. This is the origin. I take up a small square of side 1 meter by 1 meter. I bring another square of same dimensions and attach it to the previous square. So this is also 1 meter by 1 meter. This is at a distance of, let us say, 2 meters, and this corner is at a distance of, again, say 2 meters. First of all, I want all of you to use your common sense and logic to give me the centroid of this composite area. See, now I am calling it as a composite area because this complete area is composed of two smaller squares. And what I want you to do is,
Sir, 3
okay, what is the answer?
3 or 3.
3
3
comma
comma
3.
3.
That is wrong. Wrong answer.
1:1. 1:1.
Okay, you are also wrong. But before anybody else attempts, let me bring up the correct concept first. Can we agree that if I'm asking you to find the centroid of the complete area, then by logic I already know that this is here. Do you agree or not?
Yes, sir.
If I had asked you to find the centroid of the individual squares, then you would have said the first square has a centroid here, the second square has a centroid here. But now as a composite area, where will the centroid be? The centroid will be here. It will neither be here nor be here. The centroid will shift to this line. So this is the centroid and this is the partition line. So centroid has to lie here. So using this common sense, I know that the distance from y-axis is 2 plus 1. So this is 3. So if I am asking you x bar comma y bar of the composite, this is 3 comma. What is the
2.5.
vertical distance? It is 2.5. It is
2.5.
not 3. So this is 3 comma 2.5. This is the answer. Did you understand this? So the concept that I'm trying to get through to you is that you know the centroid of a square, you know the centroid of a rectangle, you know the centroid of a triangle, you know the centroid of a semicircle, you know the centroid of a quarter circle. These centroids are already known to you. You know the formula also. But now the question is, if I start combining these quantities, would the centroid remain the same? No, the centroid will shift. For example, if I take up a semicircle and I combine it with a quarter circle like this, this is a quarter circle, this is a semicircle. So you know, individually, the centroid of the semicircle will be here. The centroid of the quarter circle will be somewhere around here. But where is the centroid of the composite area? You don't know the location. Now this is where the method of moments comes into help us. Now I will explain the concept of method of moments with the help of the same figure here. So our answer is 3 comma 2.5. Okay, for this composite area. Now let us see how the method of moments works. I will redraw the figure. This is my composite area. This is 1, this is 1, this is 1, this is 1. So let me call it as area number 1 and let me call it as area number 2. Okay, and these distances are also given. This is 2, this is 2. Now we are studying method of moments. So method of moments says that your x bar can be obtained by this following equation: a1 into x1 star plus a2 into x2 star whole divided by a1 plus a2. Now let us understand what this formula implies. First of all, you see I am multiplying a1 with a distance, I am multiplying a2 with a distance. Now what is x1 star? X1 star is equal to distance of area 1 from y-axis. Similarly, x2 star is equal to distance of a2 from y-axis. So whenever from now onwards I put a star, you simply assume that it is the perpendicular distance of this one. Since I am using x1 star, it is the distance of a1 from y. Since I am using x2 star, you assume that I am using the distance for a2 from y. This is the concept that you have to remember. Now let us see whether we get this answer or not using this equation. By logic, we already understood that x bar has to be at 3. Now let us use this equation and see whether we are getting it or not. So what is a1? I am using this equation. What is the value of a1? Anybody?
1.
1 meter square.
1 meter square multiplied by what is the value of x1 star? X1 star means the distance of centroid of a1 from y-axis.
2.5.
Okay. So
Papa
this
ka
is
phone आ रहा
2.5.
फिर से.
2.5 plus what is the value of a2?
1.
1 multiplied by what is x2 star? X2 star means the distance of centroid of a2 from y-axis.
3.5.
It is 3.5. Okay, whole divided by the sum of two areas, that is a1 plus a2. What is
2.
the value? It is 2.
3.
2.
So what is the eventual answer for x bar?
3.
3.
It is
3.
2.5 plus 3.5 divided by 2, that is 6 divided by 2 is equal to 3. The same thing that we intuitively obtained. Okay, now you do the same thing for y bar. So if I want to find the value of y bar or the y bar distance for the composite area, I know that there are two areas. So what I have to do is a1 multiplied by y1 star plus a2 multiplied by y2 star whole divided by a1 plus a2. Now I want you to apply this formula to this. All of you do this on your own. This is a1, this is a2. This distance is given 2, 2. All sides are 1. Quickly calculate the value of y bar using this formula. Again, A1 is 1 multiplied by what is Y1 star? Y1 star is the distance of centroid of A1 from the x-axis. This distance,
2.5.
2.5.
2.5, plus A2 is 1
3.
multiplied by
2.5.
again the distance of the centroid of A2 from the x-axis.
3.5.
This is again 2.5. How will be how could it be
2.5.
2.5? See, this is the same distance, no? The centroid of A1 from x and the centroid of A2 from x, they are at the same distance. It is 2.5, not 3.5. So it is again 2.5. Did you understand? If you are confused, you have to ask me. Don't accept everything at face value. If I am telling you something and if you do not understand, you should ask me कि सर ये समझ में नहीं आया. ये clear हुआ कि नहीं हुआ? भाई अभी हम distance from x axis को y star बोल रहे हैं. This is y1 star. This is y2 star. ठीक है? और चूंकि दोनों एरिया एक दूसरे के बगल बगल में बैठे हैं तो x से जो डिस्टेंस मेजर होगी x एक्सिस से वो तो सेम ही होगी. जब आप y से मेजर कर रहे थे तब अलग अलग आ रही थी, x से तो सेम ही होगी ना. डिवाइडेड बाय a1 plus a2 is 1 plus 1, so this becomes
2.5.
5 divided by 2, 2.5 meter. Is this correct or not? Check it here. See, y bar is 2.5. Got it? So today you have learned the basics of finding the value of x bar and y bar using the method of moments. So essentially what you are doing in the method of moments is you are taking the moments of individual areas of the composite section, adding them together and dividing it with the total area of the composite. A1 plus A2 is nothing but the total area of the composite. This whole thing is A1 plus A2. So method of moments is exactly this, and this is the start and end of the concept. There is nothing else to discuss. In the next class, we will take up a few examples from the textbooks and more complicated problems so that you will become very well versed in the concept. Okay? So method of moments involves finding the moment of individual areas of the composite about the both axes, adding those moments and dividing with the total area. This will give you the location of x bar and y bar. We will practice with more questions in the next class, but for now we will stop here, and please don't go away. Let me take your attendance. If there is anything that you have not understood, you have to let me know. आप मेरे से पूछें. जैसे कल भी एक स्टूडेंट का फोन आया था संडे को. he had a small meeting with me और उन्होंने अपने डाउट्स क्लियर किए. तो लेक्चर में आपको कोई भी चीज अगर नहीं समझ में आती है, इट इज योर रिस्पॉन्सिबिलिटी टू कॉल मी अप एंड आस्क मी. अदरवाइज आई विल अज्यूम दैट एवरीथिंग इज क्लियर टू यू. ठीक है? आई विल क्विकली कॉल योर नेम्स. प्लीज रिस्पॉन्ड इफ योर नेम इज नॉट
मोमेंट
प्रेजेंट.
का मतलब क्या है सर?
इसका मोमेंट का क्या पूछ रहे हो बेटा, बताओ.
यस सर.
मोमेंट का मतलब आप सिर्फ इतना समझ लो कि किसी भी चीज को किसी डिस्टेंस से मल्टीप्लाई करें तो वो मोमेंट हो जाती है. जैसे कि एक पत्थर रखा हुआ है, एक छोटा सा पत्थर है. इस पत्थर का मास जो है, लेट अस से इट इज 1 ग्राम. यू इमेजिन एन एक्सिस. एक्सिस अपन को इमेजिन करनी पड़ती है. देयर आर नो रियल एक्सिस इन रियलिटी. ठीक है? एक्स एक्सिस और वाई एक्सिस भौतिक संसार के अंदर कहीं भी नहीं है. So all this x and y that you are using are imaginary and they can be put anywhere according to your convenience. तो आपने इस पत्थर से कुछ दूरी पे x और y को assume कर लिया, and now you simply want to find what is the moment of this stone. So it's nothing but the object quantity. अब एक पत्थर की क्वांटिटी अगर मैं पूछूं तो क्या हो सकता है? या तो वो वॉल्यूम हो सकता है या मास हो सकता है. अभी फिलहाल मैं इसको मास ले लेता हूं. So it is 0.001 1 kg. ऐसा क्यों लिया मैंने? बिकॉज इट इज प्रेफरेबल फॉर मी टू टेक ऑल द क्वांटिटीज इन एसआई यूनिट्स. एसआई यूनिट्स. तो एसआई यूनिट ग्राम नहीं है, एसआई यूनिट किलोग्राम है, तो इसलिए मैंने 1 ग्राम को 0.001 kg ले लिया. नाउ दिस इज द ऑब्जेक्ट क्वांटिटी. नाउ आई सिंपली हैव टू मल्टीप्लाई इट with the distance to any axis. So if I am trying to find out the moment of the mass about the y-axis, then I will take this distance, this x distance, and I will call it as x star because this is one quantity. So multiplied by x star, this is the moment. तो अब अगर आपसे कोई पूछे ये मोमेंट क्या है, तो आप सिर्फ इतना सा जवाब दे सकते हैं, कोई भी चीज लेके आ जाओ, पत्थर, फूल, पहाड़, आदमी, लाइन, एरिया, वॉल्यूम, मास, bring anything, multiply that anything with a perpendicular distance from an imaginary axis. The quantity that you get is called as the moment of that object about that axis. अब आप एक्सिस चेंज कर दोगे, अभी मैंने y के अबाउट निकाला था, अगर आप x के अबाउट निकालोगे तो ये मोमेंट चेंज हो जाएगा. सो नाउ मोमेंट अबाउट x एक्सिस फॉर द सेम स्टोन ऑफ द सेम मास विल चेंज. अबाउट x एक्सिस इट विल बी, अब ये जो डिस्टेंस है आई कैन कॉल इट एज y स्टार. ये डिस्टेंस मुझे नापनी पड़ेगी. So if I measure this distance, again the moment will be 0.001 multiplied by y star in meters, and the value will be, the answer will be obtained in kilogram meter. This will be the unit if I am taking the moment of a mass. If instead of a mass I take area, then the unit will be meter square into meter, that will be meter cube, as we have been doing till now. अगर मैं लाइन ले लूं, एक लाइन लेकर के उसका मोमेंट निकालूं किसी एक्सिस के अबाउट, then the unit will be meter square. मोमेंट का कॉन्सेप्ट क्लियर हो गया क्या आपका?
इसका यूनिट का एक
Yes,
और
sir.
बार बता दो सर.
Yes, sir.
क्या चीज, क्या बता दें?
मूवमेंट की यूनिट.
यूनिट,
मूवमेंट की यूनिट.
मोमेंट की यूनिट जो है वो किस चीज का मोमेंट ले रहे हो उस हिसाब से चेंज होती रहेगी. फॉर एग्जाम्पल ये देखो, लेट मी ब्रिंग इट हियर. अगर मैं मास ले रहा हूं और उसकी डिस्टेंस नाप रहा हूं, तो मोमेंट अबाउट एक्स एक्सिस विल बी किलोग्राम मीटर. अगर मैं मास ना लेकर के वॉल्यूम ले रहा हूं, तो उसके सेंट्रॉइड की डिस्टेंस मैंने नापी, लेट अस से अबाउट y एक्सिस, एंड आई एम कॉलिंग दिस एज x स्टार. देन द मोमेंट ऑफ दिस वॉल्यूम अबाउट द y एक्सिस विल बी इन मीटर क्यूब. तो वॉल्यूम का मान हो गया और डिस्टेंस मीटर में हुआ, तो इसकी यूनिट आ जाएगी मीटर रेज़ टू पावर 4 में. तो देखो, अगर मैं किलोग्राम का मोमेंट लेता हूं तो किलोग्राम मीटर, अगर वॉल्यूम का मोमेंट लेता हूं तो मीटर क्यूब मीटर, अगर एरिया का मोमेंट लेता हूं तो मीटर स्क्वायर मीटर, यानी कि मीटर क्यूब. तो एक ये एंड में मीटर तो जुड़ता ही जुड़ता है, ये तो फिक्स है. अब ये डिपेंड करेगा कि किस चीज का मोमेंट लिया जा रहा है. अगर मास का ले रहे हो तो किलोग्राम मीटर, वॉल्यूम का ले रहे हो तो मीटर क्यूब मीटर, एरिया का ले रहे हो तो मीटर स्क्वायर मीटर. बस इतना सा ही है. यूनिट चेंज होती रहती है डिपेंडिंग ऑन द एंटिटी फॉर विच यू आर टेकिंग द मोमेंट. अगर लाइन का ले रहा हूं तो आप बताओ, एक लाइन है, इसका मोमेंट ले रहा हूं, इसका यूनिट क्या होगा बताओ?
मीटर स्क्वायर.
मीटर स्क्वायर. Length of the line is meter, distance is always meter, so meter meter, meter square. क्लियर हो गया? यूनिट कैसे लेते हैं मोमेंट का?
यस सर.
ठीक है, नाउ वी विल स्टॉप।
और सर ये जो डिस्टेंस
डिस्टेंस हमेशा मीटर में, परपेंडिकुलर डिस्टेंस फ्रॉम एक्सिस।
और सर जो डिस्टेंस जिससे मल्टीप्लाई करते हैं उसको क्या कहते हैं?
वो क्वांटिटी, इस केस में क्वांटिटी लेंथ है, इस केस में क्वांटिटी एरिया है, इस केस में क्वांटिटी वॉल्यूम है, और इस केस में क्वांटिटी मास है। इट कैन बी एनीथिंग। ठीक है, क्लियर हुआ कि नहीं हुआ ये बताओ।
Yes, sir.
यस सर।
ठीक है, चलो देन वी विल स्टॉप द लेक्चर।